Okay, coming back. There are two more things that we really need to talk about. One, what is R squared? We've talked about it kind of, and yes, it is. It is R times R, which means it's the correlation. It's the correlation coefficient times the correlation coefficient, R times R squared. And that's fine, but that doesn't really tell you what it is. And R squared comes about a lot in more advanced statistics, but we need to have a basic understanding of what it is for our purposes right here. And the best way to talk about it is talk about error, because that's really what we're kind of talking about. Remember, here's our data set, and what we said is error, which means the residual, is that vertical distance from the observed value down to the predicted value. And here we have a residual where, when we did this originally, the observed value is 3.92 for an SAT score of 1200, meaning this person got a freshman year GPA of 3.92. But when we dumped 1200 into our equation of 0.0039 times the SAT score minus 1.47, what we got is we got a predicted value, a y hat, of 3.21. So y observed minus y hat gave us a residual of 0.71, and that's how far we are off. But R squared talks about how far we are off at every point. And the loose way of talking about it is the amount of error that our model can actually account for. And what is our model? Well, our model is this line. That's our model right there. And here's the problem that we have. Keep in mind that we are using one and only one variable to predict freshman year GPA, and that is SAT score. Therefore, our graph is linear because it's one variable, it's linear. It's not one variable times another variable like x squared. It is just one variable, so therefore it is linear. And what we're saying is freshman year GPA is predicted exclusively by SAT, math, and verbal score. But if we think about it, that doesn't make a whole lot of sense, because there are lots of other things that are going to influence what your freshman year GPA. Probably other things that are much more important that are actually going to influence, such as the classes that you're taking, the major that you have, the teachers that you have, the school that you go to, how many hours of sleep you had the night before, and if you're working or not, and how much you're partying, which you shouldn't be doing, by the way. But all these things are going to be there. And, you know, whether or not you're having problems with spouse, significant other, whatever, all these things are going to influence. But we're choosing one variable only. And unless we have a perfect correlation, chances are for freshman year GPA, that one variable is not going to do it. And our R squared was 0.66, which says that our model accounts for 66% of all the error that there is in this model. And actually, that's not too bad. But that's not what you're going to write, because that's not what the AP people want to see. So what is it that you're going to say? You are going to say exactly this, or exactly this. Your response to what is, when they say, explain what R squared means in this situation. Your response is, the amount of variation, meaning how y varies, variation in y, and it's in context. In our situation, it would be the amount of variation in freshman year GPA, accounted for by the variation, two i's apparently in variation, variation in x, whatever your x variable is. So it's the amount of variation in y in freshman year GPA accounted for by the variation, ooh, that's just horrible handwriting, in SAT scores. That's what you're going to write. If you see this in a multiple choice question, you're not going to see probably this exactly. But look for the variation statement and talk about the variation accounted for by. That's going to be an important part of this. Yes, you can expect that when they talk about R squared, in some way in a multiple choice question, they're going to try and trick you with something about the sum of the squares or the least squares line, which it's not. This is the response that you're going to give. If, on a free response question, if you say this, woo! Billy's a good boy. Good boy, Billy. Way to say the right thing there. Okay, the last thing we need to talk about is computer output. In our class, we do not have the ability to use computers. We have Excel, but then again, well, you know it, I know it, our computers suck. So we don't have that opportunity. But they expect us to use computers. So what they're doing is they are giving us computer output, and we're expected to recognize that. Here is a sample of computer output that will be generated on the AP test or my test or something like that. There's a lot of information here. First off, it says dependent variable is, in this situation, it says fair. And my guess is that this is talking about taxi cabs or something like that. So dependent variable is fair. For us, this would say dependent variable is freshman year GPA. Okay? Then it gives you a value of r squared. It gives you as percent. Even though the calculator gives you a decimal, understand they're the same thing. It does not give you r. There is no r listed here. But I do have r squared. Can I find r if I have r squared? I certainly hope so. I certainly hope that I know that the square root is the inverse of squaring, so I could take that value, make it 0.482, and take the square root of it to find what r is. But the problem is that your calculator, when you do square root, is always going to give you a positive value. So, is r going to be positive or negative? How to make that determination? Well, r should have the exact same sign as slope, so if I can find the slope, then I will know, because I might not have a graph. Okay, where is the other information I'm going to have here? Here we have this interesting piece of information. It says S equals 41.82 with 18 minus 2 equals 16 degrees of freedom. This value before the minus 2, and it is minus 2, that value right there is your sample size in case that ever comes up. But what we're looking for is we're looking for the word coefficient. Underneath the word coefficient, we're going to see two numbers. One of those numbers is going to be the y-intercept. One of those numbers is going to be the slope. Looking next to the word coefficient, we see the word variable. And underneath the word variable, we see constant, and then we see, and in this situation, it says dist. But this right here, whatever this word is, that's your explanatory variable. So it says up here, dependent variable is fair. Down here, it's saying that the explanatory variable is dist, which means that this is probably distance, and this is fair. Again, thinking like a taxi cab. For us, this would be dependent variable is freshman year GPA, and then down here underneath the word constant, this would say SAT. Constant is something that is added in an equation, and that would be the y-intercept. So the value next to constant is the y-intercept. Here, this value is 177.215. That would be the y-intercept. Here, this value underneath coefficient next to the explanatory variable, that is the slope. So, looking at this information right here, because they have 177.215 as the y-intercept, they have 0.078619 as the slope, your equation would be y hat is equal to 177.215 plus, because it's positive, 0.078619 times x. For us, because our y-intercept was negative 1.46, this value right here would be negative 1.46, and our slope would be 0.0039. Now, understand that the best answer you can give works like this. Your y hat could be said fair hat, because you are predicting the fair. For us, it would be freshman year GPA hat is equal to. And then instead of x, you would put the explanatory variable. Here it is distance. For us, it would be freshman year GPA. But again, because you're going to be asked to, from this, find the equation for line of best fit. Next to the word constant is the y-intercept. Next to the other word, which is going to be your explanatory variable, is going to be the slope. We are just about out of time. Hey, you know what? That's chapter 8. That's great.